Welcome, everybody. Thanks for being here. We're very excited about this episode of Construction Tech Tuesday with Sandra Rohler of Cornerstone Architecture. The Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Willy, we have launched Construction Tech Tuesday to share the technique, and the technology of passive house construction tech. Each week, we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week. And thank you for being here. With that, I will pass it to Kevin.
I'm Kevin Brennan. I'm happy to be here tonight and have a introduction from my friend Sandra Rohler, who I met in 2012 when I took the Passive House Tradesperson course given in Ireland. I'm going to share my screen. I might have a few throwback photos from that event. So this is the event here. You can see this video playing if it plays for you guys. And that's myself, and I was on the team with Sandra, and we won the competition. That's Sandra right there, picking out a piece of foam, myself, JP, and we won the competition of the mock-ups that day. And we had a great time. It was an eclectic group of people from all around North America who was taking the course for the first time, and it was a lovely experience. Another picture of Sandra in the background there, working on the mock-up hard. The first time where we interacted, that was our group there on a site project, a site visit that we did out there. And then fast forward a few years after that, when I was working for the Passive House Academy and Tomas O'Leary, and I had the lovely pleasure of coming to BCIT and doing a train the trainer with Marcel and Sandra at the BCIT facility. And this is a quick little shots of that training that they did. They designed these lovely mock-ups, these mock-ups that were cut in four, and they were able to come together and piece together. They were great. We had a great experience. The hands-on was great. And that's Sandra working with the rest of the BCIT staff there, showing them how it's done with the hands-on experience. And a good friend, Scott Kennedy there, showing the wall mock-up that I think we'll get used to a little later. So Sandra, it's been a pleasure to know you. It's been a pleasure to call you a friend, and it's been a pleasure to watch your career grow and where you've gone in the Vancouver region. And I'm very excited for your presentation. So I'm going to kick it off to Sean.
Mark, do you want to say hello first?
Sorry.
Sure. I always love the flashbacks, Kevin, of this is kind of a point in time of Passive House and the different faces. Wonderful. Real quick, my name is Mark Willy. I am a longtime carpenter. I'm a materials guy. Very excited. Recently sent a big old semi full of engineered wood up to our friends in the north. So bless your hearts for receiving that. And I just want to give a quick shout out to everyone that was here last week. We had a whole bunch of conversations about training, and we covered the many training facilities, including EMU, and many of you reached out for the discount code. So we hope that you continue that conversation and move it forward. I love the fact of Kevin sharing the story from Ireland to Vancouver and the importance of these trainings. So it's on all of us to share that and to make it a part of our own community. So if you're looking for when the next trainings are happening, let us know. We will extend those dates and locations. Sean, take it away, brother.
Hello, everybody. I'm actually excited. I got my dad in the crowd today, so I not only brought a friend, I brought my best friend to the show tonight. So we can all wave to Steve. Say hi, Steve. Thanks for finally showing up on week 17. make him feel nice and happy in his office. So good to see you, Dad. I'm excited to introduce this amazing individual. I got the opportunity to learn the Passive House Tradesperson course from her. And are you guys ready for these accolades? She is an registered architect from Germany, Passive House designer and project manager at Cornerstone Architect, which we're going to see in shortly the project she's been working on. PHI certified Passive House designer, PHI certified Passive House tradesperson, lead AP, certified joiner and furniture maker. That one we're going to talk about in the overtime today because that's pretty cool. Co-founder of Canfi West and Passive House Canada, and as I just said, instructor for Passive House Canada and BCIT. Talk about accolades. She's amazing, and we're going to dive into some of her latest great stuff right now. So Sandra, let's turn it over to you and let's talk about this cool project.
All right. Thanks, guys. Thanks for having me. Where do I start? So we're going to talk about Little Mountain a bit. I can tell you that much. I prepared a full-on presentation and then decided to change the subject an hour ago because we have good news, and I'll share that with you as we go through this. So I'm going to put this. How about I start sharing my screen? And I would like to just point out that there is probably lots of you in the audience that might know more about this subject we're going to talk about. So this is really meant to start a conversation. Little Mountain Co-housing. So I was going to talk about a bunch of details and how this all came together and the complexity of the project. But I think, let me just get started. Little Mountain Co-housing, just for the few of you that are familiar with Vancouver. Now, obviously it doesn't go. There we go. So, okay, you see this screen. Okay. Location, Vancouver, Quebec Street. This is Main Street. This is 33rd Avenue. This is Hillcrest Community Center, Queen Elizabeth Park. This is our site in an area that's called Little Mountain. This is how it turned into Little Mountain Co-housing. Just to give you an idea of how the building looked like, this is our design model. So it is a co-housing project which has 25 suites, large amenity spaces, guest suite and common workspace. This is the model, and this is a photo of how it looked last week. If everything goes well, and it must go well, we are going to get occupancy on Thursday this week. So it is pretty recent, and also we just had our blower door test done, and as of an hour ago, we know that we passed. It was
congratulations.
It was quite a process. It was quite a process, as we almost didn't. So the first result didn't come in properly, but then we started to look at our calculation again. And so just to back up a bit, when Sean asked me a while ago to pick one detail, which I guess what this presentation is typically about, pick one detail on Little Mountain that was challenging to present, I thought to myself, oh boy, which one should I pick? They were all challenging. And I started to put together a presentation of a lot of details and a lot of thermal bridging reiterations that we did, and about the fact that we had added concrete in the end, and all these things that made it very, very work intensive, I would say. But then in our dry run last night with you guys, it turned out that the really important part I should be talking about is the AV ratio and how that affects potential blower door test results. And so I took a step back and basically thought about complexity on a project versus keeping it simple, because one of the challenges and positive challenges on this project was that it wasn't just a developer project, but it was a co-housing project. So co-housing, just a brief introduction, co-housing as opposed to co-op housing, that's a whole different story, means that you have an owner-developer group. The owners form the development group and develop this project. Then they have one designated apartment each, and basically when the project's finished, the first right of refusal. That's probably the easiest to explain. But in essence, we had 25 owners, really probably 50 owners. And obviously each of them had their own idea how their apartments should look like, right? So that led to 13 different suite layouts in a 25 suite building. So there's one challenge right there. Talk about stacking. The other one, and the major requirement for this group altogether, apart from affordability, diversity of households, environment for children, supportive community living, environmental stewardship, was under supportive community living. They really wanted a common courtyard allowing visual connection, right? So that was something that if you look at the side of the design process, and then you look at what the passive house design process really wants us to do, design compact, you can already tell that kind of didn't go hand in hand. Then I'm not sure if anyone of the city of Vancouver is in the audience, but we also have to revisit our design guidelines, because they don't really support the passive house design process per se. Too many setback requirements and such. Different story though. But we had to obviously consider those ones too. And then in the end, what we also had, because we had 13 different suite layouts, we had insufficient shear wall space, right? So there weren't enough walls that would actually align to make this project work properly. And then we have these very high seismic requirements here in Vancouver. So now that basically, we tried to avoid concrete wherever we could to avoid thermal bridges. Also, that didn't really work that well. And then here's another interesting one. So as a trainer and instructor for Passive House, I learned on this project that we're doing things we wouldn't teach, yeah, like a toilet over an exterior space. So these were all, and there are other things, but this is just one example for requirements or wishes really versus what's best to keep it simple, right? This is another one. This is just more for interest, but there was the requirement or the wish we had to do a bathroom off a townhouse stair landing, which was over the main public entry corridor. Yeah, so you can imagine fire rating issues, height issues, drainage challenges, all of these. Now going back to, so this is what I just wanted to skim through yesterday, and the guys kind of told me to focus on this more. So I think most of us, you've taken the Passive House course, you've taken some Passive House course. Yeah, so you've all seen this slide, and I don't want to focus on this much. We all know as we kind of make our building more complex, we have to add insulation. Yeah. Now we've also all seen this one, right? So this is the AV ratio, which is the surface area to volume ratio. And as the number is lower, obviously the AV ratio is better. So in here, this is the AV ratio of Little Mountain, yeah? And that came straight out of the fact that we're kind of having this U shape as opposed to a more compact shape. And this all turns into a full-on loop at the very end, so bear with me here. To understand what happened, so there was a design process, and I have to say at this point, I can't take any credits for the design. I came in at design development stage, after design development permit. So this was really a collaborative design between Scott Kennedy and Simon Richards, partner of Cornerstone. So we had different approaches. That was all before my time. One was very compact. I'm going to flip through it. Compact, but that was the compact floor plan. Yeah. And then it turned into this beautiful courtyard area. So the idea was to have this common courtyard, to have exterior pathways to access each floor. And so all of that added to the heat loss surface. And I make it sound like it's a bad thing. It's not. Yeah, I'm just explaining why things are the way they are and what the challenges are that come out of this. This is a great design. I mean, I've been in this building so many times, and it's really gorgeous. So this is oh yeah, this is the photo that Sean jumped over the fence for today. So this fresh off the press. This is today, really. So you can see this is the back. These are the exterior pathways, and the courtyard, and the front you've seen before. So again, just to quickly go through this, to look at the layouts. This is the courtyard here in the back. This is the main entry. These are 4 townhouses here in the front, and then we have very large amenity spaces. This is an amenity lounge here. This is an amenity space with a big kitchen, laundry, children's, and I'm going to flip through it a bit faster so we can stay with my 20 minutes here. Now we're going up one. Townhouse still, 4 townhouses, interior staircase, elevator, and now you can see here, this is where the units start. And these units for 3 stories, they're actually stacked. You will see as we go up, nothing else is really stacked. And this is an exterior staircase that goes all the way up to the roof garden. And these are the exterior pathways that basically connect this part of the building with the other part of the building. And every floor level has this little meeting area, really, with a big window, which is quite lovely. Yeah, so this is goes up and up and up. It changes, you see that. And now this is our setback. Gorgeous big patios. Again, this is a design guideline to have those setbacks. It also has to do with floor area and FSR calculation. There is another big amenity room here with a big neutral roof deck. And then there are 3 big units on this level. This is level 6. And here is the roof garden. The neutral roof garden shared. This exterior staircase goes all the way up, and then we have garden beds here. That's the building as it stands today. Now, in terms of our air tightness, and this is really what I want to get to, maybe a quick run through our wall assembly again. We know that the air change ratio required is 0.6 minimum. And the wall assembly we chose was the same wall, and this is where it gets interesting. It's the same wall assembly Cornerstone has used, and that was before my time. I wasn't involved on a different project, which we all know under the Heights, or Skeena. It's probably the first multi-residential passive house in Canada. So we use this for many reasons. This has been discussed before. I can just run you through the framing sequence. Actually, we should just look at this quickly. So you can see here the way it's framed. We have a 2x6 on the exterior, then we have foil-faced EPS in the center, and we have 2x4s as an installation cavity. And our air barrier system is basically the foil face taped and sealed, and it goes around here. And then we have our MyVest wrapping around the rim joist and tying back into this. So that is part of this system at this point. Quickly through this, we put the MyVest on there, call that the floppy bit. Then the wall goes up, the floor goes up, we flip it around and we tape it. And so here's an interesting one. We have to obviously make sure the interior walls don't, we must keep a little bit of an area here to fiddle in the quick therm and the installation layer after. So now this is how it goes. The windows are coming, we tape and seal them. Then we insulate this part, and then comes the quick therm or the foil faced EPS. Turned out to be a different product in the end. And then there comes the installation layer, and this is kind of how it finishes up. And now this is now how it looked in reality. Obviously all a bit messier, but it totally worked. And so this is the building. So you can see here some of these details, and I just wanted to share some details. This is now all these rim joists with the MyVest nicely wrapped around. So maybe here's the one detail I picked for this presentation. And there is again, like all these, this is the exterior pathway on each level, and the MyVest is wrapped around here. And then this pathway is attached to the exterior wall. This is changed. This is now a cal door. These are all obviously passive house doors that go off this pathway on every single level. There's some more air system. We had another, we like challenges of course, so we put in a little bit of a round wall, yeah, just to make it more fun. And then some more MyVest photos here where it kind of wraps around. And then here's the sequence as they were actually installed on the inside. The MyVest comes in, it gets taped down to the bottom, and then this is the quick therm just for measurement. And then they basically just, they did it a bit differently than they did it on Skeena. So they kind of taped it up here first and then slid the quick therm in and basically taped it up. So this is kind of how we continued the air barrier on this part. So I think in terms of time, I can show you 20 more details, but I think we should really talk about the big news of the day, that we actually passed the blower door test. And I was going to tell you a bit of a story about this because, and there's no slides, but I think I can talk about it as we did last night. And you know what, guys, if you have questions, maybe just to chip in and we make this more of like a discussion. I feel pretty lonely in this little space here talking to my screen. So the blower door test, you saw, because of this exterior pathway, we didn't have one volume, right? So that was one of the challenges. And because we didn't have one volume, there were different ways to actually run the blower door test with like exterior hose connections and such. But the idea from the beginning, and mainly the final decision also, was to create one volume just for the test. So the equipment was installed on the 3rd floor, and we basically put big holes into the party walls to make it one volume. Now, as you guys know, the final test has to happen close to occupancy. Occupancy with holes in the party walls is not going to fly. So it was kind of very, very close together. The first test came in at 1.1 air changes per hour. And then they ran 4 more tests, and in between they basically fixed leaks, closed leaks, adjusted windows, adjusted doors, all of these things. And then, and that was roughly a week ago, the final test, at that point, the final test was 0.69. Awesome building, yeah, great building, way beyond any code, but obviously we know 0.69 is not 0.6. It's also not 0.649. So, and now I have to see what I'm going to disclose. Anyway, I make this short. We revisited our volume calculation. And I basically took all the guidelines and kind of looked into, I looked at it like we at Cornerstone, you know, you guys know we have Scott Kennedy and he challenges this code everywhere he can. Yeah. And that's great. So I did the same with the certification guidelines. I didn't challenge them, but I kind of looked at how they could potentially be interpreted. Yeah. And so I kind of discussed all of these things with our certifier. We took another day to revisit all of our volume calculations. And as of today, we had a final volume of 6,556. And that turned into an air change rate of, oh, I didn't even write that down. Oh, of 0.62. So that's basically the news of the day. But what we found interesting is, and we're still trying to wrap our head around it, and this is kind of open to discussion. So I'm showing here a comparison of the numbers between Little Mountain and the Heights. And so the Heights, or Skeena, had the same wall assembly. On Little Mountain, we have 3 inches of EPS versus the Heights has only 2. You saw the form factor. Obviously, we needed a bit more insulation, right? On Little Mountain. But other than that, it was basically the same. There were 2 things that are changed. And that is the quick therm, foil-faced quick therm was replaced by foil-faced airboard, taped and sealed. And then the My Vest, which I believe on Skeena, the exterior, which was the weather barrier, but not the air barrier, was also taped and sealed. So that was maybe an additional air barrier part or air barrier, but we're still trying to wrap our head around why they came in so differently. And obviously one explanation is the building is extremely complex, right? Little Mountain is very complex and it has a very different form factor. So the heat loss form factor of Little Mountain is 1.27, whereas the one on Skeena is only 1.112, right? And then we have the surface to volume ratio at Little Mountain is 0.57. And then on Skeena, it is 0.42. But what's interesting is that our Q50s are so different on this almost same wall assembly, right? So you can see here, this is where Little Mountain sits, right here on this area of like a 2-story block. And this is where the height sits, which is kind of 6 stories high, fairly compact building. So all that makes sense.
Well, Sandra, if I could jump in here.
Jump in. This is good timing.
So as a blower door tester myself, I do my own blower door testing. I do them on larger buildings, and it's always a challenge to seal complex shapes and areas. So the metrics in which you're talking about for this project on the Canadian standard, the performance levels of the Q50 number are as close to the definition of an air barrier as you get, you know? So I think it's 0.007 liters per second per square meter. For us American, IP people, I think it's 0.002. And then that's for the material. And then there's the assembly. So that's all the tapes, the auxiliary components, the caulks, the sealants, and then that number triples. So you're right at the limits of the material itself from a laboratory when we're doing passive house. So that level of precision and excellence is not easy to hit. When you have easy just membranes and sheets attached, they're great. But when you start having to do inside corners, outside corners, tapes, connection details of windows and penetrations, it starts to get a little more complex, and the margin of error increases, as well as the surface area increases, and your volume decreases, as you pointed out, with the area to volume ratio. So when we're measuring a PHI project and we're using ACH as our metric, you increase the surface area, you decrease the volume. Now that number becomes a little harder to hit. And the inverse is true in high-rise buildings that are very compact shapes, 27 stories stacked on top of each other, has the opposite effect where it's easy to hit the ACH number. So on the other side of the border, the FIAS crew have decided to use the Q50 number for a permeance leakage rate for the projects that they're doing. So I think it's a 0.05 CFM per square foot. I'm not exactly sure what the metric version of that is off the top of my head. But there's two different ways that we're measuring leakage rates, but they both matter. And the pass-fail ratio that is agreed upon internationally through PHI is the ACH. But there also is Q50 numbers as well that could be.
The Q50 is for at this point for PHI certification at this point for this building is not required. That might change, but I think the other point I also wanted to point out really more from like with my two hats on, like from the builder side, but also the architect side. We've always kind of said air tightness is up to the builder, right? It's the builder's responsibility. And I would tend to say that is actually not true, because we had, well, first of all, we had the same wall assembly, we had the same contractor on both projects, and we even had the same site super and the same air tightness champion, and they did tremendously good jobs. Yeah, so I think what I want to actually remind everyone of is that we as, now I've got my designer hat on, we as designers have to make sure we keep it simple. I can't say it any other way. Keep it simple. And even in talking to the site super the other week, I just asked him, is this building very complex? And he looked at me as if I was talking about something completely outrageous. He said, what kind of question is that? I've never seen a more complex building than this one. So it is fairly involved, and it didn't make it easy. And I have to say, I didn't know I've always been very passionate about passive house. I didn't know that a blower door test can make me so emotional, but this last week, really trying to make it work was quite intense.
One of the differences in FIAS, they have two air tests, right? One is to test the envelope itself. And in that case, you can tape up, if you had like a fire door it was just going to be a leaky device, you're allowed to tape that up for the Q50 test, but then you untape it for the air change per hour test, which is what you put in the energy model. So there's sort of two separate tests. One is really testing the durability of the envelope, and the other one is testing, the air leakage of in total for the energy model. And I think that's actually a good thing, and it's not part of PHI. But I actually think that in my scientific brain is probably the better way to go. But now you got to do two tests.
So it's good, and it's challenging as well, because when you're doing that final blower door test, you're really doing almost four tests: pressure, depressure, and then pressure, depressure. And the two terms are enclosure integrity, and then the final one, I forget what the name for it is, but one is just testing the air barrier systems itself, and then the later one is testing the gas, the dampers, and everything else that's supposed to be closed. So you're almost unmasking everything. And my lessons from the field of doing projects is you really, really need to make sure that your masking is bulletproof and isn't going to delaminate, because doing four tests really puts a lot of stress on some of those masking products. So we go with a very heavy duty 6mm adhesive poly that sticks to it. And we do a decent amount of prep work there. So it's a challenge.
The other thing I would like to mention in terms of what's different between the two is that Skeena had like a semi-centralized ventilation system versus Little Mountain has an HRV in every unit, right? So we have way more penetrations there, and during the air tightness test, because the scaffolding was gone for the final test, so they couldn't actually access all of these intake and exhaust hoods anymore. So they taped the HRVs on the inside. So I actually am very confident there was not any leakage in the ducts because we used the Zenda pipes. They are pretty tight by itself. But that might also not contribute to a better result, right? As an additional, just an additional difference between the two buildings.
Yeah,
Well, go ahead, sorry, Kevin.
masking is always a challenge. I worked on one project where they needed to do a man lift with the individual ERVs just to seal them from the outside and check each one of them. So it was a decent amount of work to get there. And the lesson learned there was maybe to install like a temporary damper in the closet so you can just like shut it closed, like real simple HVAC damper that would have prevented needing a man on a lift to seal, man on a lift to seal everything. But that plan up front was a lesson learned.
We actually did air tightness testing today on another co-housing project that started out as a passive house, but unfortunately didn't end up as a passive house for a bunch of cost saving reasons. And the leaks were, funny enough, they were in the windows. They are triple glazed windows, but they're just standard kind of vinyl frame windows. They found leaks there. And of course the doors it's all exterior doors. It's a 5-story building. All the doors are exterior. All of it is deck access. There are no connections between suites whatsoever to do a tightness test. So you have to leave holes all through the building, which is very difficult. And they hit points. It's almost 3 separate buildings. It's like 3 towers with these walkways in between them and a courtyard in the middle of the U. They hit 0.7 on one and 1.3 on one and 1.2 on the other, which I thought was pretty good for
No, you did.
what we call probably a step 3 or step 4.
But
Probably
did
step
they
4
test
building.
they test it to the passive house protocol? Can we compare those numbers?
I think so, but I don't know the full. I just heard about it about an hour ago. So,
All right, everybody, good stuff. I think let's dive into some questions. Thanks to Scott and Will for chiming in and answering a bunch of stuff. But first, Sandra, cheers. Not an easy project, but love your passion. So, cheers to you and the rest of the Cornerstone team for pulling this off. And if anybody missed it, if you want to learn more about the Heights, Scott and Giza did a presentation back in December 16th on the happy hour. I threw that in the chat, so you can always go back and check that. And where Scott tried to have as many slides as our current slide presenter with Ian, who had about 248 slides, plus or minus 20. So again, a great presentation that Scott put in there. So let's dive into the questions. John.
Hey, Sean.
Yes, Mark.
Before we do questions, I loved your toast. Can we do a quick unmuting and toast for the blower door celebration of today?
Absolutely.
Everyone, please unmute yourself and give applause to the crew.
Cheers, everybody.
Yay.
Cheers.
Cheers. Cheers.
Little louder, little louder.
Cheers.
All right.
Little louder.
Sandra, you get test results on Friday.
Sorry, John, what was that?
We'll give Sandra our test results for our non-passive house by Friday. Scott
Okay.
was a bit off on those.
Okay, John, I'm going to hold you to that. Good to see you, by the way.
And where
Thanks for
were
joining.
you when we needed you?
You get rid of that.
But
Phone call away, brother.
Better,
John,
better mute me real quick.
Yeah, no worries, buddy. We'll bring that up in the overtime. But till then, let's dive into the questions. We got John.
Hey guys,
Oh,
Sandra,
there
Scott,
you go, bud.
good job. Thanks for the presentation. My question, Scott kind of answered it in the chat, but maybe you guys might want to elaborate. What was your approach to cantilevering the decks the thermal bridging and the air tightness strategy there. And then after that, just a quick comment on what were some of the most compromised things for the air tightness test that you might have fixed and figured out to bring the numbers down.
The deck, are you talking about the wood decks?
Yeah.
I can pull up, I can actually pull up the IFC set if that helps. That might help a bit.
I think, John, one of your questions was about the air tightness. So one of the things about the volume is you net out all the interior walls and you basically work to the inside face of the drywall. And so one of the things we hadn't done that we were able to do was to include, when you have a door opening, technically the door becomes part of the volume, which we hadn't done. So when we added that in, that made the volume go up a little bit. And also there was a debate about drop ceilings and beams and whether you measure to the drop or you measure to the top and a few of those kind of pieces. And there was a long chat with the certifiers and came up with a strategy for all of those things. And then when they all got added together, we were able to get that 0.69 drop just enough to get us to the certification, which is really what we were trying to do. It was so important to this group that we get it there. And we just couldn't find a major leak. It just seemed to be, there was nowhere that we could point to say that's the leak that we had. There was a few badly adjusted doors, and those things are always happening in every building. One of the things I'm actually thinking about doing is telling a contractor to buy their own blower door, actually put it into the building and suck the air out of the building for 2 or 3 days before we even get there. So you can send somebody around to adjust all the windows and get all that stuff done before we go there, because a lot of time gets spent just chasing those kinds of leaks and finding those things. And especially on these big 6-story buildings, that's a real trick. And I think I would suggest that you do that. So that's one thing we're doing. And the other thing I'm starting to do is creating a penetration schedule. That came from Prudence's presentation the other day. And I've done that for the first building and we put it into the spec. So who's responsible for what and what we expect them to do. So I think those are all important things.
Scott, those are great points. And one thing to add in there is the blower door guarded air sealing it's invaluable. It's something we do on every project that we chase our leaks of our air barriers and systems. One other thing that we've recommended doing is when they're adjusting their windows, the manufacturer, whoever's installing them, to just throw a blower door inside of the apartment or the door just to get some pressure on it, and then they can check it with a smoke stick, because a lot of times they're making the adjustments with just visual inspection and the gaskets and stuff. The other thing is choose your worst door or window that you know is your worst door or window to check. It's your one cheat you get under the PHI or European norm. So use the worst door. A lot of times it's the one on the bulkhead or maybe like an access door. So use it if you got it, and then keep the good ones good. So that's my little cheats.
I'm next, John.
Yes.
Thank you.
You have a bunch.
Well, they mostly got answered in the chat. Thank you very much. But I am curious about the blower door test, this is a very complex building, and I'm just curious, how was it segmented off, and how did you go about doing the blower door test in terms of?
Well, it wasn't actually segmented off, so there were different approaches that we had a pre-test walkthrough with the testing company, and they actually came up with a full-on report as to how to prep the building. And during that walkthrough, and I believe there's actually I filmed this walkthrough, and I think they posted that online as a YouTube video. So part of that discussion was about how to test it, and the assumption from the beginning on, and again, this is where we tested it the way it was planned, but I'm also going to say right now that air tightness testing should become part of the planning process very early on, right? And not air tightness testing, especially on a passive house project, can't be an afterthought. It has to be part of construction sequencing, really. And then in this case, as I said, we made it one volume for the test. And so we put holes into the party walls wherever the volumes wasn't one. We put like, what did they say, 5 by 5 feet, like roughly 1 square meter, a bit more, into each party wall to make it one big volume. And then, I mean, the size of these holes had to be substantial to keep the air moving freely. And then the install of the blower, I mean, yes, they ideally, you try to find the worst door. By the way, PHI's requirement is really not to install it in the doors, right? Because they want you to test those bad doors, but they usually let us get away with it. But in this case, the blower test equipment to make sure it's all equalized, or the most equalized, if the pressure and depressurization is equalized, was in the center of the building. So we put it on the 3rd floor, in one of the doors of this hallway, of this pathway.
I'm wondering, is there a maximum size of volume that you can do with one blower door test? I'm just thinking of stack effect, and I know putting it in the middle might take that into account, but I'm just wondering if there's some losses that we're not quite taking into account when we go this big.
Well, this project itself, and even Skeena, is not too big for one piece of equipment. I guess it depends on the size of the test. I mean, again, if it's not a passive house building and you might end up having very different air changes, maybe that is not enough. I really only know this for passive house buildings, where
blower door testing gets easier in passive houses, because as the buildings get tighter, you need less fans. But the fans you use will vary, and as you increase the volume and the size, you will need more fans, or you would need high-powered fans. There's some manufacturers that have high-powered fans that run on DC, and they can get a lot of flow out of them. And then sometimes you just have to stack multiple fans in the door frames. I've seen one project where they used 62 fans on a very leaky building, and all at once, and that is not easy to coordinate all that data coming in and monitoring it. So blower door testing in passive house does get simpler, as leakier buildings are harder to test and get accurate data.
I mean, what also came up in this whole context was mid-construction testing, right? So the city of Vancouver actually requires mid-construction testing in their passive house verification plan. But again, because we were so successful on delivering Skeena with such a nice air change ratio, it's not me, I can't say we, Cornerstone was, and we used the same wall assembly. We figured that we can just do without it, and they let us do it. But now the whole discussion comes up again, but the discussion is also, and this is all like reality, right? So this project had so many ever-changing traits, yeah, and then COVID hit, and then people wouldn't show up, and then others would show up, and so a mid-construction test tells you about one segment of the building. So if the next crew is not the same one building the rest of the building, what is it worth? Like really, it's kind of a really an interesting question. The mid-construction test, obviously, I'm getting there because you asked about the equipment. That is where you kind of really need to pressurize or depressurize adjacent units, because those party walls have no air seal, and so this is when you start having like lots of equipment to just do that one test.
Sandra, we've actually on a few projects that we've done guarded blower doors where we're measuring one floor at a time. Mm-hmm. And we've gone through a lot of effort to isolate the hoist, the construction hoist, the stairwells, the elevators. It's not an easy test, and the data is not really, it's questionable to say what.
I mean, right? It's a lot of effort, and it takes lots of time. It always is money, right? And stops the construction process for a time, which is even more money. And so the question is, what are you getting from it also, right?
So we did 4 projects with that, I worked on as a consultant on those projects. And then the last project I worked on, we did what is known as chamber testing, ASTM 783, where we would test a window and a wall, and then we would know the leakage rate of that window and wall. We'd attach it to the wall, and then we would randomly go around. That was good feedback. So that's something I think as an industry, we should kind of like standardize to the passive house level, because ASTM 783 is written to leakage rates of windows and air barriers and stuff. But what we really need to know is what's the leakage rate at 50, and are we going to pass or fail our blower door? So it's something collectively I think we can all come together on, and standardizing that practice and getting it more formalized, because it's a lot easier to take an 8x8 chamber, attach it to a wall, seal that off, tar it out, know what the leakage rate of the chamber is, and then know the leakage rate of your window and your wall connection, which is your most vulnerable connection details in most assemblies, and then know if you're on target. The other thing that we've done too is the performance mock-up early on, the first runs, run a blower door test on those to know what your leakage rate is. And then what comes up is the ACH versus the volume, the Q50 numbers. The ACH numbers in very, very small structures are not accurate, because you will never hit 0.6 on a 10 by 10 structure. But you have, if you know what the Q50 numbers are, then you know you're close to what your leakage rate is. So something we all need to have a larger discussion on.
I think testing those window install mockups is something we should really look at. I agree with that. Windows and doors, right? I find what's really challenging in passive house, and you guys probably all know this, is find really good air sealed, low threshold doors. It's just somebody please start producing them locally as a market.
Sandra, one thing I've been trying to convince the larger projects I'm working on as a consultant is that first run mock-up is the construction office or where they have their meetings, and it stays on the project from start to finish. And every time they get a new guy, they have to walk through and be like, these are the details, this is how it looks. And it's a great product to then also get you from air barrier to facade and then to finish, and you can help you make design decisions. But it's also a very nice place to have meetings in a cold construction site that are quiet. And there's something magical about going into a quiet room in a passive house on a construction site that says, this stuff works, because they've got a jackhammer outside and we're having a normal conversation and able to communicate. And it's something that opens up, and it get buy-in from all the trades. You know, the electrician that walks in and has his subcontractor meeting on a Monday says, oh, I have an impact on this. I make penetrations. If I don't make them right, maybe, it may not be as airtight. So just those little things. I'd like to.
That's actually a big thing. I think that's great. I mean, if you can sell that idea to every developer, or contractor, I think that's very beneficial.
So since this came up tonight, Kevin, on that idea of the room, let's go ahead and place a name on that room so that other people can create this room and create videos. Do we call this the funky room?
That sounds a little weird, Mark.
That sounds a bit loud, though.
Really, it's on-site. It's the mock-up, so maybe the mock-up might be better.
If it doesn't have PH in it, we're not going to accept it. So let's keep it open, and we'll do a poll next week. How about that?
I love it.
As Sean would say, put a pin in it. We have
right,
4
folks.
more minutes, Sean. So
yeah, so we'll time out on the questions first. We'll go back to Sandra. Sandra, do you have any mentors you want to talk about and give praise to before we turn it over to Zach for updates?
Sure.
We're at that time. Yeah.
Mentors. I do. 1 second. I gotta.
Oh, the fun house. I like that one. That was good.
Fun house.
Susan.
So just so you know, like I had another 200 slides, but I think we're good, right? See here, share screen. So I would like to, can you see this? Yeah.
Yeah.
I would actually, as my mentors, when I think of mentors, and this is not working, there we go. I'm talking about people that supported or inspired me. And so I would like to really point out 3 people, which is Fred-Jürgen Stürmer, architect WDR in Germany. Yeah. One of my big mentors and very inspiring people. Sorry, I'm looking the other direction because the slide's not on my camera. This is rude. And then the other one is Andreas Nordhoff with EBN Passive House Technique. I took the Passive House Designer course with him in 2010. I finally took the course. Then went back to Germany for that. And he offered me a job after I've taken the course. It was back then, it was like a 5-day course with the exam right after. So it was very condensed. And since I was in Germany, he offered me a job, but turns out he had a mechanical engineering office. So I actually ended up working in a mechanical engineering office for 6 months, calculating volume flows, damper sizes, and worked on PHPP expansions of schools and banks. Very inspiring, very passionate person. And then last but not least, I'd really like to mention Adam James, friend of mine, architect here in Vancouver. He supported me very much through this horrific process of getting registered in Canada as an architect. I was always registered in Germany, but man, did they not make it easy here. So thank you very much to Adam on being there, even though he had no time himself.
Thank you, Sandra. Great stuff. And one of these days too, we'll get Adam presenting if he can ever find the time. You guys are just always too busy doing too many cool passive house projects. So Zach, let's give us the scoop.
Yeah, absolutely. So I want to take a moment to thank the folks that make Construction Tech possible and the Happy Hour possible, the podcast, all of the work that we do at the Accelerator. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Insulation and Airtightness, Innotech Windows and Doors, and US Engineered Wood T-Stud. Check out our podcast episode this week. It's a very special podcast with guest podcast co-hosts Mary James and Ilka Cassidy, and they are interviewing Gabby Brainard and Nina Sharifi about the envelope retrofit guide, about the experience of passive house as women and the role of passive house in moving forward architecture and technology. It's very, very cool interview. Tomorrow we have a wonderful presentation from Manon Meskens of the Belgian, and she'll be speaking about the Belgian retrofit case studies that A2M has been involved with. A2M Architecture is a leading passive house architecture firm globally, based in Belgium, and Manon is the New York City lead. So we just saw her run through. It's a great presentation about 2 cool retrofits. Next week on the Construction Tech, we'll have Ed May and Amy Fiella of Building Type and Baxt Ingui Architects, respectively, presenting about the road to excellence. So this is about the teamwork involved in creating passive house projects between the architect, the passive house consultant, and the builder. So join us next week. We'll see you soon.